Hello, everyone. Good morning. I hope you guys had a restful night. We do have our end of course exam coming right after this. I want to thank you guys for really paying attention to this. I know some of you guys are going to take it very seriously and you're going to try your best. I know some of you guys might get very distracted. To those of you that are doing that, please know that this is the last time that I'm asking you guys to really push yourselves to try your best. During the other exams, I've noticed a few of you guys have given up, have pretty much just sat there, not done what you're supposed to do. I don't want to see any of that during my geometry exam, guys. I know you guys have it in you to be amazing at this. I know a lot of you guys struggled with geometry. I know it's very different from algebra, but I want you guys to know that you guys know all of this stuff. You just need to recall it and do your best to listen to this review. Okay. And then a small disclosure for those of you that actually tried this last night and did not get the correct answers, I want to apologize to you all because if you tried it, you would have noticed that the multiple choice answers were actually not correct. So, anytime I make these sort of assignments, I usually add the multiple choice questions just so that make it easier for you guys. This time it failed me, and the system did not create them properly. So if you were doing question one, for example, you would have noticed that none of these are the answer, which is really tough if you were trying to do it by yourself and you just kept getting stuck. That is 100% on me, guys. I'm very sorry. But we're going to be going through this anyways. Just ignore the multiple choice. Just think of it as a FRQ question, right? So no further delay. Let's go ahead and get started. This is going to be about 45 minutes. I'm not going to do all of them. I'm only going to do some of them. And I hope you guys can take it upon yourselves to pause the video if you want to and just try a couple on your own. Okay. So let's go ahead and get started with number one. The endpoints of a segment are 1, 2, and 5, 6. Which equation represents a line that is perpendicular to the segment? So redraw right. The first thing I want to do is just draw a segment. You guys have done that before. 1, 2, and 5, 6. Now, what they want is they want to draw a segment that is perpendicular to the one that we just drew. So basically, they want one that is 90 degrees. Now, we don't know what the endpoints are for that one, but we do know one thing. Anytime that you have the word perpendicular pop up in geometry, it could mean one out of two things. It's either explaining that it's a 90-degree angle, which means it's a cross, or it could also be telling you that you need to flip and switch. That is called the negative reciprocal. Okay, so you need to find the negative reciprocal slope of the original segment. That is not as hard as it sounds. First, let's go ahead and get our slope. I'm going to mark this as x1, y1, x2, y2. You should always do that. Anytime you see coordinates, mark them. Right? Now, my formula to find slope is this one right here. Y2 minus y1, change of y. X2 minus x1, change of x. Don't forget about slope, guys. We're going to go ahead and substitute those into that formula, see what happens. So my y2 is 6, my y1 is 2, my x2 is 5, and my x1 is 1. 6 minus 2 is 4. 5 minus 1 is 4. That means that my slope is 1. Okay, that's it. Now, if I want to create a slope that is perpendicular to 1, I would have to do this. Flip and switch. Now, I can flip a 1 over 1, but it's still just going to be 1. So if you want to flip and switch a 1, it ends up just being negative 1. You flip the fraction and switch the sign. So it went from positive to negative. So I end up with this number right here, which is just negative 1. None of these answer choices are negative 1, but that would have been the slope of whatever equation they create for the other line. That's pretty much it. So again, I'm sorry if you guys were doing all that work last night and you guys just couldn't find the right answer. That was on me, okay? Now, what about something that's parallel? Again, these are not going to work. Parallel means same slope. That means that whatever equation I create has to have the exact same slope as whatever this gives me. So I'm going to go ahead and do the same thing. y2 minus y1, and x2 minus x1. Now my y2 is going to be 3, my y1 is going to be negative 1, my x2 is 7, my x1 is 3. Now this turns into a plus, so it's 4. 7 minus 3 is 4, and I end up with 1 once again. This time, however, I don't flip and switch it. I keep the same slope. So whatever equation I have needs to be the same exact slope in order for it to be an actual equation. Now let's say we had an answer D down here, and it said y equals 1x plus, I don't know, let's just make one up, plus 6. That would have been your answer. That would have been your answer right there. It's parallel because it has the same slope. So please don't forget about that. Perpendicular, you flip and switch the slope. Parallel, you keep the same slope. In addition to that, remember this process. This is how you get slope from a set of coordinates. y2 minus y1, x2 minus x1. And it's on your reference sheet, so please don't forget. Moving on to triangles. This is going to get a little bit interesting. I'm not going to use a calculator. And the reason why I'm not using the calculator is not because I'm not, I don't want to do it or I'm being lazy. The reason why I don't want to use a calculator is because I know that some of you guys might have been working on this without a calculator. Tomorrow or today, whenever you're watching this video, you're going to have a calculator in front of you so you can actually work these out. Okay, so Pythagorean theorem. Everybody knows Pythagorean theorem. A squared plus b squared equals c squared if you have the two legs and you need the hypo. If you have the hypo and you need one of the legs, you would switch it to a minus problem. Please don't forget about that. Now, the way I did these is they might seem a little more complicated than they usually are, but they're really not. Okay, they're really not. A right triangle has legs of lengths 3/4 and 5/6. Find the length of the hypotenuse and simplest radical form. Disregard that. That does not matter. You have calculators that will convert anything into a decimal. All you have to do is just click Control Enter and it will turn into a decimal. So if you want to turn this into a decimal, you can. You want to turn that into a decimal, you can. So what would this look like? A triangle has lengths of 3/4 and 5/6. I'm going to go ahead and draw it. The legs are the ones that I have, not the hypo. So I can make this one into 3/4 and I can make that into 5/6. It does not matter what they tell you guys. Any side that they give you, just put the number there. If you don't like the fraction, turn it into a decimal. Put it into a fraction. This turns into 0.75, right? So you can just change it into 0.75 and do Pythagorean theorem like you normally would. Please don't let these types of questions throw you off from just Pythagorean theorem. It's just Pythagorean theorem. That's all it is. Let me show you another one. In a right triangle, one leg measures 5 units. So I'm going to go ahead and draw my triangle. One leg, any leg, doesn't matter if it's A or B. And the hypotenuse is radical 61. What the hell? Radical 61. Some of you guys are going to panic and say, well, what the hell am I supposed to do that with that, right? It does not matter, guys. Put it on NSOLVE. Put it on whatever you want. We have the hypo, so we're going to use formula C2 minus B2 equals A2. My C2, which is my hypo, is going to be radical 61 squared minus 5 squared equals A squared. It does not matter. These are inverse operations, actually, but it does not matter. The calculator will do it for you. Convert that radical 61 into a decimal and then put it into your formula. It does not matter. I added this Pythagorean theorem because I know you guys know how to do it, but in the case that they throw something at you during the exam that has a radical or a fraction, don't panic. Just put it into your calculator just like that, or convert it into a decimal first using Control Enter. Okay, so please do not panic. Pythagorean theorem is very easy, guys. Please remember that if you have your hypo, subtract the leg from it. If you need the hypo, add the legs. Okay, moving on. Triangles, area of triangles. This is my favorite, for sure. What triangle has the larger area? I'm actually going to work this out and give you guys an actual number. Okay, so let's try it out. Area of triangles In the two-dimensional space, the formula would be half times base times height. Okay? So anytime you see that area of triangles or any kind of area, find the formula on your reference sheet. Go and find it. If this is volume of cone, volume of cylinder, go find the reference sheets. Okay, go find it and understand exactly what you need to be using. Any kind of formula that you need, go find it. Legs measuring 6 and 8 meters, hypotenuse measuring 10 meters and 6 meters. Okay, so this is a Pythagorean theorem problem where you will need to find all of the sides in order to have the information necessary to fill out the formula. And we did this when we were working with transformations. We were looking at the coordinate grid and we needed to do a bunch of Pythagorean theorems in order to find all the sides of a triangle. Now this is easier because you're giving it to you and you don't have to do a bunch of Pythagorean theorems. So for triangle A, let's do it right here. Triangle A. For triangle A, you have a triangle with legs that are 6 and 8, and you don't have a hypo. You don't have a hypo. However, the formula for an area of a triangle is just half times space times height. So you don't need the hypo. You already have the base, which is perpendicular with the height. So you don't need to find the hypotenuse. The hypotenuse doesn't matter to you in this case. This is all you need in order to be able to find the area. So we're going to get that area of this triangle, 6 times 8, and it's going to be half of 48 is 24. So the area is 24 meters. That's it. Now let's look at triangle B. Triangle B has a hypotenuse measuring 10 and one leg that's measuring 6. Now let's call that the height. Right? Now it's bothering me that this height is not blue. So I'm going to change it to blue over here. The problem with this is that you don't have a base. Now, a lot of you guys are going to try to use those too, but you have to remember that in order for it to be a base and a height, they need to be perpendicular with each other. They need to create a 90-degree angle. So the hypo is not the base or the height of this triangle. It's just the hypo. So we need to find the base. So in this sense, we do need to use Pythagorean theorem so we can find our base. So we're going to do 10 squared minus 6 squared equals base squared. Remember, I'm looking for my base, so I'm not going to call it my leg. It's actually my base. So it's 100 minus 36 equals b squared. 64 equals b squared. The square root of 64 is 8 equals base. So my base is equal to 8. So let's go ahead and do a quick math. Half times base times height. My base is 8. My height is 6. It comes out to exactly the same, which is 24. So which triangle has the larger area? Neither. They're both 24. How cool is that? We used Pythagorean theorem to understand all the sides of the triangle that I needed, and I picked the sides of the triangle that I needed in order to get the area. It doesn't sound so advanced, but if you're capturing the situation, your brain is starting to think in different ways and you're starting to put things together. So we understand the area, we understand Pythagorean theorem, and we understand how to compare those areas. That's an awesome question. Problem 2, you can try it on your own. Go ahead and pause it if you need to, okay? Let's go ahead and go to Unit 3, Inequality Theorem. I added this just because I know 2 years ago they added a few questions regarding that. 2 years ago it wasn't a blind assessment, so I very clearly remember them telling us inequality theorem was going to be present, and it was. So I'm going to remind you guys of what it is. During class, we actually got some pipe cleaners and we cut them into colors. It was purple, yellow, red, orange, yellow. I don't remember what they were. But we cut them into different sizes, and when we put them together, trying to figure out if we can make a triangle or not. There are certain rules that need to apply in order for it to be a triangle. So the rule is that the sum of two legs has to be greater than the third side. Not equal, not less, but greater. So let's go ahead and check it out. Two sides of a triangle have lengths of 6 and 13. Which side of the following could be the length of the third side? Let me go ahead and move this a little bit. And let's try that again. So, if we're using 7, 6 plus 7, the two smallest sides, if I were to add them, 6 plus 7 is equal to 13. Is 13 equal, less, or greater than 13, which is the largest side? It's equal to 13. So this is not a triangle. Hopefully that reminded you guys of this. It's been a while. You add the two smallest sides and see how they compare to the third side. 20 units. 20 plus 6. I'm sorry, I did that wrong. The two smallest sides are 13 and 6 on this one. So it would be 13 plus 6 is 19. That is greater. No, less than 20. So it is not a triangle. Next one. The two smallest ones are 6 and 5. So 5 plus 6 is equal to 13. That is equal to 13. So it is not a triangle. And lastly, we have 19 units. So 19, it's 6 plus 13. That is 19 is equal to 19. So it is not a triangle. So this is another one of those questions where, unfortunately, which one of the following could be the length of the third side? None of them could be the length of the third side. It has to be greater. So 6 plus 7 is equal to 13. 13 plus 6 is equal to 19, which is less than 20. 5 plus 6 equal to 13, which is the same as 13. And 6 plus 13 equal to 19, which is equal to 19. So none of these can be your third side. Multiple choice sucks sometimes, but that's okay. What could be an option for one that works? Let's see. What about if we had 10 and 6? So 10 and 6 would be the two smallest ones. 10 plus 6 would be 16, which is greater than 13. So 6 can actually be one of them. Now, what's a better way to do this? What if I just wanted to find all the ones that could match? There's another thing that you can do, which is find the inequality of it. The inequality theorem, which states that if you subtract these two numbers and add those two numbers, you get the two limits of what it could be. So 13 minus 6 is what, 7? 13 plus 6 would be 19. So any number between 7 and 19 could be a choice. Not including 7, because it doesn't have an equal sign. So it doesn't include 7, and it does not include 19. It has to be greater than 7 and less than 19. So that means that 8, 9, 10, 11, 12, 13, 14, blah, blah, blah. Any one of those numbers could be it, except those two that I have there. So any number between 7 and 19 will work. Okay, moving on. Two sides of a triangle have lengths of 9 and 15. Which of the following could be the length of the third side? Instead of doing all of this, I'm just going to go ahead and do my inequality right away. 9 plus 15, that is 24. And 15 minus 9 is 6. So any number between 6 and 24, not including 6 and not including 24, could be the answer. So again, none of these answer choices are going to fit. 5 is less than 6, 24 is equal to 24, 6 is equal to 6, and 25 is greater. So none of those can be an answer. But any number between 6 and 24 could make a triangle. Okay? Wake up, guys. I know you guys are falling asleep. Wake up. Let's knock this out. Shortest to largest side. Now, this one was actually half of a lesson of one day. So if you don't remember this, I completely understand. But I taught this in the form of a flashlight. I was telling you guys, the bigger the flashlight, the bigger the angle that it creates, the side that it creates, right? So if you light a flashlight on a wall, the bigger the flashlight, the bigger the light on the wall. That's how I taught it to you guys during the year. That's basically what it is. So the bigger the angle, the bigger the side that it creates, the opposite side. So I'm gonna draw this out, A, B, and C. Let's see if it even equals, yeah, it equals 180. So we're good on that. This is a triangle. I have a 35-degree angle, an 80, and a 65. So I'm gonna try my best to draw it. Actually, this is gonna be something like this. So this is gonna be, maybe I'm being too technical here. There you go. So this is gonna be my 80 degrees. I'm just making these up, by the way. I'm not doing anything special. This is gonna be 65 degrees, and this is gonna be 35 degrees. All right. Now 35 degrees is angle A, this is angle B, and this is angle C. Now what it's saying is, which one of these is the biggest side? Which one of these is the shortest side? Now the way you do that is by drawing to the opposite side. This angle is creating this side. This angle is creating this side. And this angle is creating this side. So the bigger the angle, the bigger the side that is creating. So if I want to get the shortest to largest, all I have to do is start with the smallest angle. So the smallest angle is 35 degrees. It's creating a side called BC. So BC is the shortest side. The second smallest angle is 65 degrees. That means that it's creating a C. That is my middle side. And lastly, I have 80 degrees, which is my biggest angle. It's creating my biggest side, which is AB. So these are the segments from shortest to largest. BC, AC, AB. BC, which one is the longest? The longest is AB. So the answer is A for that one. Okay, let's try the other one really quick. And again, don't worry so much about getting the angles perfect. It doesn't really matter that much. It's pretty much almost the same angles actually. So I'm going to draw kind of the same one. This is going to be 80 degrees. I made it just below the 90. This is going to be 55, and this is going to be 45. 45-degree angle is X. This is Z, and this is Y. Now, shortest to largest. The shortest is going to be opposite of the shortest side. So YZ is my smallest angle. XZ is my second smallest, and my largest side is YX. There you go. How to find or how to identify the smallest to largest sides based on the angle that's creating them. Cool. Moving on. Oh, let's see what the answer was. Which side is the shortest? The shortest one is YZ. So the answer for that one was B. Cool. Almost there, guys. Trigonometry. Now, trigonometry is pretty cool. You guys know how to do it on the calculator. I'm not going to use the calculator, but I would tell you what to put on your calculator so you guys can do it right after I do it. Inverse trigonometry is when you have a triangle, a right triangle specifically, and you're missing an angle, but thankfully you have two sides. So this is when you have a lot of sides, but you don't have an angle, and you're trying to find out what the angle is. That is inverse trigonometry. So as you can see here, you have an angle that you want. That is called your reference angle. I'm going to draw an arrow outward. It's going to call my opposite, my hypo, opposite of the 90 degrees, and my adjacent. Okay, I'm going to do the same thing over here. This is going to be my opposite. This is going to be my hypo, and this is going to be my adjacent. Now I'm going to do SOHCAHTOA because I'm a good student that listened to Mr. Santi. And because I'm doing inverse trigonometry, it's going to have that -1 on the top, right? There you go. Now, what side am I not using in this first question? H. That means that I can't use sin and I can't use cos. I can only use TOA. Let's look at the next one. I'm not using adjacent at all, so I can't use TOA and I can't use cos. So I have to use sin. The question is asking, how do you get the angle? Inverse trigonometry says that you can do that by just creating a ratio without NSOLV. Why no NSOLV? Because O on top of A creates the ratio just fine. O on top of A, 27 on top of 38. You do not have any missing variables, so you don't use NSOLV. Put this on your calculator, it'll give you an angle measure. Okay, now let's do this one. Sin, -1. O on top of H. O is 40, H is 42. Put that on the calculator without NSOLV, and it'll give you an angle. That is inverse trigonometry. You use the sides to find the angle, and it will be on your exam. Okay? Trigonometry is what happens if you don't have enough sides to do Pythagorean theorem, but you do have at least one side, and you have at least one angle besides the 90 degrees. So let's read this quick question. An 8-foot metal wire is attached to a broken stop sign to secure its position until repairs can be made. So I'm going to draw a stop sign. I'm not about to draw an octagon, guys. It's going to be stop. And the metal wire. Let's go ahead and make a metal wire here. I'm going to make it like a chain link fence looking thing. This is the metal wire. And it's holding up the stop sign that got broken. The wire makes an angle of 51 degrees with the ground. Cool. So this is the wire, this is the ground, obviously. So it's making a 51 degree angle. Cool. With the ground. How far from the base of the stop sign, this is the base of the stop sign right here. How far from the base of the stop sign is the stake holding the wire? So there's actually a stake right here holding the wire down. And what they want to know is how far is that stake from the base of the stop sign. So what they want to know is X. There you go. Now there's a couple of things to consider. An 8-foot metal wire they're telling you the hypo already. The wire is 8 feet. So you have the hypo. You need the adjacent. So I'm going to change the color a little bit. This is the opposite. This is the hypo. And this is the adjacent. If we're doing SOHCAHTOA, regular SOHCAHTOA, because we're finding a side, we're not using the O. We don't want to know how tall the stop sign is. If it had asked how tall is the stop sign, then we could have put the X there. But they wanted to know how far it was from the base. So we're going to get rid of anything that has an O on it because we don't want the opposite side. We want something that uses the A and the H. Okay, so the way you set this up on your calculator is you go to trig, you choose cos. It's going to open up parentheses for you. You're going to put the reference angle in here, which is 51 degrees, and A on top of H, X on top of 8. Now, you don't have to use NSOLV for this. You can actually multiply 8s on both sides. Put this on the calculator, and it'll give you the answer. Or, if you don't know how to do that because you don't know how to algebraically manipulate an equation to solve for a variable, that's fine. You could just put this whole thing on NSOLV. And it'll give you the value of X. Again, I'm not going to do it, but I'm giving you guys the tools to do it yourselves. And that's how you do that. Okay. I'm going to do number 3 really quick. I'm going to do it pretty quick because I think trigonometry is really important, and I know there's going to be word problems. Now, the word elevation is going to come up. Don't panic. Elevation just means that it's looking from the ground up. So from a point on the ground, the angle of elevation, I'm going to go ahead and draw it already. Let's see. I'm going to go ahead and draw my triangle. If I'm looking up, I know that I'm going to be at the bottom over here. This is elevation, and this is depression. Okay, so this is depression, and this is elevation. Because you're elevating your head to look at something. So somebody's looking at a plane at a value of 23 degrees. The airplane is up here. The airplane is flying at an altitude of 1,200 meters. Altitude is a vertical height, so it's always going to be a vertical line. What is the straight line distance from the observer to the airplane? Now, they had to include straight line distance because if you looked up distance, you might have thought that it was the bottom. But the straight line distance from the plane to the observer would actually be the hypo. So they're not looking for the adjacent side. They're looking for the hypo. That's going to be my x. Okay, now, if I have SOHCAHTOA, I have my opposite side. I have my adjacent. My adjacent I'm not using at all. So I can get rid of cos and TOA and use sin. So my equation would be and solve sin reference angle, which is 23, and angle of elevation, O on top of H, 1,200 on top of H, which is my x, comma x. There we go. That's what you put on your calculators, guys. And that's it. That's how you do trigonometry. Feel free to replay that if you need to, or if you didn't understand it. But let's move on to Unit 7. We got about 3 more pages. Hang in there, guys. It's not that much. About 5 pages. What am I saying? So, what is the image of 4,2 after reflection over the line y equals 5? The image, blah, 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 after reflection over the line y is blah, blah, blah. So this is kind of like a sentence stem. It's really not that hard. Let's check it out. 4,2. So 4,2 is right here. The mirror is at y equals 5. Remember I told you guys, y equals 5 means that it's literally going, it's a line that's going through the y-axis intercepting at 5. And that's the same thing for slope as well. If it said y equals 5, slope, it literally means just 5. It never touches the x-axis, so we don't involve the x-intercepts. This is my mirror. So let's take a look at what the reflection would be if the mirror was at y equals 5. My reflection is 1, 2, 3 down. That means that it would be 1, 2, 3 up. So my new coordinate would be still at 4, but I would be all the way at 8. There you go. So the image of 4,2 after reflection of the line y equals 5 is 4, 8. Cool, right? Now you guys can do the same thing for x equals 1. You guys can do the same thing for y equals -1, etc. This is the one that I wanted to get to, the rotation. Rotations might sound difficult, but they're not, guys, especially if you know the quadrants. So I'm going to draw a quick quadrant to remind you guys of what I'm referring to. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay? Now, at the same time that the quadrants are labeled, we can also think of it as a clock. If you're starting right here on the top, this would be 90 degrees. This would be 180. This would be 270. And this would be 360 degrees. So 90, 180, 270, 360, full circle. That's how our rotation works. Now, it is saying counterclockwise, so we would move the other way. Instead of doing it that way, we would do 90, 180, 270, 360. Counterclockwise, against the clock, the opposite direction. So let's do it really quick. Check out how easy this is. 3 negative 2 would be right here. 3 negative 2. Now it's saying that it's going to move 90 degrees counterclockwise. Before I even look at any of these answers, I'm going to do a couple things. 90 degrees would mean that it would move from this quadrant to that one. This would be 90 degrees. This would be 180. This would be 270. And this would be 360 degrees because it would go all the way around. See? So if it's telling me that it's only moving 90 degrees counterclockwise, that means that it should end up in this quadrant right here. That's how you have to look at rotations. You have to ask yourself, what quadrant would it end up at, considering every 90 degrees, it's a quadrant. So, -2, -3, -2, -3, it ends up being right there. 2, 3 is up here. -3, -2 is right there. And lastly, 3, 2. 3, 2. So these we can eliminate right off the bat. It's got to be one of these two. Now, you don't know the rotation rules, and you're not going to remember them, even if I taught it to you a million more times. Well, that's a lie. Eventually, you would know the rotation rules, but they're really hard to remember. The important thing here is that when you're talking about rotations, they actually flip positions. So the 3, 2 would end up being 2, 3. So the answer would be, where is it? It would be A. Those rotation rules are crazy, guys. But I guarantee you that it's not going to be that close. Like most likely in the exam, there's going to be one up here, one over here, one over here, and one right there. And it's going to be very obvious that that's the answer. So please don't panic too much. That's the key to rotations, knowing what quadrant it's going to end up at. Okay? Moving on. See, 180 degrees rotation. I'm not going to do this one. I'm just going to show you. If I'm -4, 1, and I'm moving 180 degrees about the origin, this being the origin, this would be a 90-degree rotation. This would be 180 degrees. So I know that my answer has to be in this quadrant right there. It has to be. Okay, so something to consider. Dilation. Dilation. This is a fun one. Now, before you guys panic about dilation, remember, this is not anything to panic about. We actually did this in class. I'm not going to do both. I just want to show you guys how to do these problems really quick. Dilation is just basically saying, and during class I taught it to you as, whenever you go to the doctor or to the eye doctor, they ask you, we're going to dilate your eye so we can check it out or whatever. Dilating means that they put a flashlight in your eye and see how it gets bigger and smaller. So it increases in size or it gets reduced in size. That's what dilation is. There is a factor, a scale factor, in which it's reduced or increased. That is represented by K. K is the scale factor. So we're going to find out how much bigger is this second triangle than the first one. Okay, very quickly. So first thing I want to do is I want to find out what is the area of these. Now, if you want to, the reason why I put this here is because sometimes you can find the area, you can find out how much bigger it is in the first dimension by just looking at one length. Let's do that now. Check it out. So this one is 1, 2, 3, 4, 5, 6, 7. And this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the first thing you would think about is, you know what? This triangle is 2 times bigger because its length is 2 times bigger. That is true. The scale factor in the first dimension is 2. It's 2 times bigger. But what we want is the scale factor of the area. So that is not what you go off of. What you need to find out is what is the area of both triangles, and then you can compare them, okay? Just like we did here. So we have that. We have the base. We need to get the height. How tall is this triangle? How tall is it? Okay, so let's figure it out. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is 10 in length, in height, I'm sorry. So it's 10 units tall. This one is 1, 2, 3, 4, 5. This one is 5 units tall. So let's find the area for both. Half times the base, which is 14, times the height. That is half of 140. Half of 140 is 70. So the area is 70. Now let's do this one. Half times 7 times 5 is half of 35, which is 17.5. Now, check it out. When you first did your scale factor, you realize that 7 is half of 14, and you might have thought this triangle is exactly 2 times bigger, but it's actually not. Let's find out how much bigger it is. If you divide 70 divided by 17.5, you end up getting 4. So 70 divided by 17.5 is 4. That means that when it comes to area, the triangle is actually 4 times bigger. It's 4 times bigger, not 2 times bigger. So you have to ask yourself, are they asking me for the scale factor of the lengths, the perimeter? Then it would be 2. But the scale factor of the area is 4 times bigger. You needed to find the area to figure that out. Let's do this one really quick. Well, actually, I'm going to hold off on this one because I know you guys are going to start getting bored any second now. And, well, if you're not bored already. And this requires quite a bit of work because we need to do Pythagorean theorems. So 1 and 2, 3 and 1, 2, 3, 4, 5, 6, 3 and 6. Find the Pythagorean theorem. This, find all the sides, blah, blah, blah. So we're not going to do that one. If they put anything on the test like this, it's most likely going to be like this one. So please be careful with that. What is the scale factor? Of the area, not the length. Okay. Circles. We're almost there, guys. So we're almost there. Take a break if you need to. Pause my voice. A circle has a radius of 6. When we were doing this in class, we're actually... Oh, what am I doing? I can actually do this. Look at that. Technology. So we have a radius of 6. We have a radius of 10. What is this area of the sector with a central angle of 120 degrees? So this is probably going to be around there, 120 degrees. And 90 degrees is going to be like this, 90. What is the area of the sector? Anytime I see the word area, pi r squared. And anytime I want to convert from degrees to actual tangible area, I have to use a proportion. The proportion is 90 out of 360 equals x. This is going to be my answer, area of a sector. And this is going to be my area formula, which is pi radius, which is 6, squared. There you go. Put this on your calculator, comma x, or you can do multiply diagonal, divide across, whatever you decide to do. But that is how you knock out area of a sector. Now, length of an arc which is at the bottom here, same thing, radius of 8. So it would be 45 out of 360. But instead of using the area formula, we would use circumference formula, 2 pi r. So we would change this to 2 pi 8, and this would be my answer. So this changes to circumference formula. That's what it changes whenever it's talking about length. And that's it. This one would be 120 out of 360 equals pi 10 squared. And this would give me the answer. Now, please be careful. Sometimes instead of radius, it's going to say diameter of 10 inches, in which case you would need to divide the diameter by 2 to get a radius of 5. Radius is half of the diameter. So please be careful that they're not giving you radius. We're going to see that a little bit later in Unit 9. Okay. Again, pause me if you need to. I'm going to go into inscribed angles. I'm just trying to get through this, guys. Inscribed angles is a very quick and easy reminder. And inscribed means it's written inside of something, in which case this angle is written inside of the circle. So what is the relationship between the circle and the angle inside? The inscribed angle is half of the arc that it creates. Half of the arc that it creates. In this case, angle A is only half of arc BC. So angle A is only half of BC. Okay, so if you need to find out what angle A is, you would just need to divide by 2, inverse operations. This has to be 40 degrees. It has to be 40 degrees. Okay. Now, what about the other two angles? I don't have enough information to figure that out at the moment. I don't have enough information to find out what this is or this. But let's go a little bit further and see if we can find the problem. Let's look at this one. This one I can definitely solve. I have enough information. Check it out. This angle X is only half of the arc WV. So 42 would be half of WV, which would be 84. Now that's great and all, but we can keep going. What about angle W? Angle W is 90 degrees and it's half of arc XV, which would be 180 degrees. And you can tell that this is a semicircle, so it's true. And lastly, angle V is only half of the arc. Now, I don't have angle V, but I can get it. I can do 180 minus 90 minus 42. And it gives me 48 degrees. So this is 48. How do I know it's 180? Because it's a triangle. And it's called triangle angle sum theorem. All angles inside of a triangle equal 180. So this is 48 degrees, which means that this arc has to be 96 degrees. And between all of the arcs, it should be equal to 360. So please remember inscribed angles. All of the angles are half of the arc that they are creating. That's amazing. I love it. Anyways, equations of a circle. Again, you can pause me whenever, guys. You can't do this in class, but you can shut me up here. Just take a pause, breathe, go to the restroom. Just please make sure you're not, distracting anyone. Equations of a circle. Identify the center and the radius of the circle. All right. The origin is xy. In the sense of the equation of a circle, they're actually described by y and k. That's the original equation of a circle. X minus h squared plus, and remember this is just a squared plus b squared equals c squared. That's all it is. But I want to find out what these are right here. What are the values before they were put into the equation? So the number one rule that I reminded you guys of is that if it is negative on the equation, that means that it is positive on the origin. So this -3 right here is actually a +3 for my x's. This is a +4, which means that it used to be a -4. That is my origin right there. My 49 represents my radius after it's been squared. Now, if I want to do the inverse operation to find out what it used to be, and that's why it's called a square root. What is the root of the square? Where did the square come from? The square come from the square root of 49, which is 7. So the square root of 49 equals 7. So the radius is 7. This is my answer. This is my center, and this is my radius. That's it. Easy. I'm going to do it a little bit faster. This is -5. This is a +2 because this one was negative, so it's a +2. Square root of 36 is 6. Done. 1, -6, square root of 100, 10. Awesome. Area and volume. Now this is a bunch of information. It's not really that important. I wanted to add it just in case you guys got a chance to look at it tonight. But area, these are some examples of area. Area is length times width. Triangle is half of the base times height. Circle is, these are all area. So they're squared, or they're talking about square inches, square meters, or whatever. Volume is where it gets interesting. Remember, all prisms have a formula of area of the shape of the base times the height. So if we're looking at a cylinder, that is a prism. You find out what the area of the circle is. So let's say that the area of the circle is 10. How many circles that have an area of 10 are stacked up together? That is the volume. So if there are 10 circles stacked up together that are 10 each, that would make the volume 100. That's all that volume is. The face of the cylinder is a circle. Get the area of the base, multiply it by how many of them are stacked up together, which is the height. Okay, and that is all that a prism is. How is that different from a triangle? A pyramid is not the base stacked up on top of each other. It's not. It's actually 1/3 of the base times the height. That's what it means. Oh, not one half, 1/3. So every pyramid is 1/3 of what its prism would be. So this is 1/3 times base times height. If you're looking at a square pyramid, that would be 1/3 of its base times height. They all have the same formula. That's all it is. Okay. So let's go into some problems. This is actually the last page, guys. Last page. Let's take a look really quick. Find the volume of this cone. This is 100% sure going to be on the test, guys. They always put a cone question, always. Let's take a look. The volume of a cone is 1/3 of pi r squared. Now, why is it 1/3 pi r squared times height? The reason why it's pi r squared is because this is the formula for the base of the cone, which is a circle. So I'm going to put a small little reminder here. This is the big B stands for square, which is length times width. It could be a triangle, which is half times base times height. Or it could also be a circle, which is pi r squared. So if I say that this cone is 1/3 the big B times the height, the B in this case is a circle, which is pi r squared. And that's where that formula comes from. So it's 1/3 times pi r squared times how tall it is. So let's do it really quick. 1/3 times pi, the radius is 8, squared times how tall it is. We do not have the height. Do not worry. You can find the height. You have a triangle right here in which you can use Pythagorean theorem. So when it comes to cones and any kind of pyramid, you might need to use Pythagorean theorem to find the height. So we're going to do a separate little problem over here. We have the hypo. So it's 16 squared minus 8 squared equals height squared. So 16 times 16 is 256 minus 64 equals height squared. 256 minus 64 is 192 equals height squared. Square root of 192. Let's see what it is. How do you do it? Let me see. There you go. 13.8. 13.8. So now I can put that as my height. And this would be my equation that you guys can put in your calculator and it'll solve it for you. That is the volume. So don't forget, whenever we're working with cones, it's just 1/3 of pi r squared times how tall it is. That's it. This one is missing it as well. So before I go any further, I'm going to do 8 squared minus 5 squared equals, let's call it height squared. 64 minus 25 equals height squared. Let me just do it on my calculator really quick. The square root of 39 is 6.2. There you go. Now I can use my formula. 1/3 the base, which is pi 5 squared, times how tall it is, 6.2. This is what you put in your calculator. The formula for a cone is on the reference sheet, but you don't have to even look at the reference sheet. Just remember, all pyramids are 1/3 of base times height, and regular prisms are just base times height. That's it. So let's look at a prism. This is a prism right here. A lot easier because this one is not 1/3 of itself. This one is just base times height. Now the height is easy. It's 8. But the base, which is a circle, is pi r squared times 8. However, the radius is not 8. The radius is only 4, half of that. So we can rewrite this as pi 4 squared times 8. That's it. The only difference between these two is that this cone is 1/3 of a cylinder. That's all that means. Okay. I'm going to do this one. This is a diameter. I don't need diameter. I need radius, which is 5. So this one would be pi 5 squared times how tall it is. That means that there are 9 of these circles stacked up to each other. So get the area of the base, multiply it by how many of those bases are stacked up together, and you get your volume. That's all it is. Last question. Do not panic if you see something like this. This is actually just at the end, you do exactly what you just did. And then at the end, you add them together. Check it out. So the cone is 1/3 pi r squared times height. The cylinder is just pi r squared times height. The radius for both is 3. And the height for the cone is 5, but the height for the cylinder is 10. So you would put this on the calculator. The volume of the cone plus the volume of the cylinder equals the volume of the composite 3D figure, which is this rocket looking thing. And that's it. You can put that on the calculator and it'll give you the volume for both of them put together. So let me just do a quick check. I put it twice. Do a quick checkup. See if I missed anything. But no, I don't believe I did. Awesome, guys. So that is the review. It'll be uploaded, ready for you guys to watch during homeroom and first period. I'm going to be walking around making sure that you guys are taking it very, very seriously. Thank you, guys.